Good morning, everybody. I'm going to suggest we get started. Apologies for a slight delay in the starting, but we wanted to give people an opportunity to join, and it always takes a little bit longer when doing these things online. So first of all, welcome to this discussion about what the challenges are to reaching net zero. So this discussion is part of the Engineering Faculty's Research Showcase, and is particularly pertinent given the news that we have been hearing this morning about the UK increasing its ambition to reduce its greenhouse gas emissions and bringing forward its targets to be more ambitious and more challenging. So I'm Guy Howard. I work in the Department of Civil Engineering at Bristol. So I will be chairing this event. We brought together 4 key panelists who work in different parts of the engineering faculty in different departments, but whose work in different areas, whose work on technologies, on research and teaching, all share the common ambition of trying to support the reduction of greenhouse gas emissions and to combat the effects of climate change. So today, each one of the panelists are going to share a little bit about their experiences or what they see as the specific challenges to reaching net zero, how the work that they are doing supports us to achieve that, and in particular the importance of the relationships between academia and external organisations, including industry and government. So our panel is Dr. Paul Harper, Professor Chris Priest, Professor Mahmoud Mostafi, and Dr. Claire Granow. So the way the session will work is we will start off with a brief introduction from each of the panelists. We then have a set of questions that I will pose to the panelists and ask them to answer. And then we will have a session at the end for about 15 minutes where we can have Q&A from the audience. So with that in mind, I would encourage any of you who have questions you'd like to pose to the panelists, could you please be typing those into the Q&A box so we can keep a track of that, and so we've got some questions ready to provide to the panelists when we get to that session. So first of all, let me make sure we go to the panel and introduce them. So in no particular order, or in the order that I can see people on my screen, I'm afraid, I'm going to start with Chris. And Chris, could you just give us a quick 1-minute introduction to yourself and the work that you're particularly engaged in?
Hi, yes, my name is Chris Priest. I'm Professor of Sustainability and Computer Systems in the Computer Science Department here. And my research is very much geared around understanding the environmental impacts of digital technology across the world, and also trying to understand the ways in which digital technology affects our behaviour, our business models, etc., and how that also influences emissions, both for good and for bad. Not only climate, but particularly climate.
Great. Thanks, Chris. Paul, can I ask you to introduce yourself?
So, hi, my name's Paul Harper. I was a student here at Bristol a long time ago. I liked it so much, I've stayed ever since. I became very passionate about renewable energy following my aerospace engineering degree here. And ever since then, my background, I guess, my key background is in composite material technologies and their applications to wind and also tidal energy technologies. But I'm also one of 2 theme leads for the low carbon energy theme of the university's Interdisciplinary Research Institute focused on environmental sustainability, the Cabot Institute. So that means I'm now lucky enough to get experience of a broad range of different low carbon energy technologies and research across the university.
Great, thanks, Paul. Claire, can I come to you next, please?
Yes, thanks, Guy. So I'm Claire Granow. My main role is actually teaching on an MSc in Water and Environmental Management. And in doing that, I guess we're particularly trying to prepare our students to take on a very different future and incredible challenges. Obviously, net zero and climate change is one of the things that our students need to contribute to, but they're also going to have to deal with the implications in terms of resource management and equitable allocation of resources and all sorts of things. So that's kind of my interest area in terms of research and teaching, and particularly this interface. We can prepare our students really well in terms of their knowledge, but how do we actually prepare them to influence the future decision making? I think it is particularly important.
Great, thank you very much, Claire. And Mahmood, finally.
Hi, my name is Mahmoud. I am a Royal Academy of Engineering Research Chair in High Temperature Engineering. I happen to work a lot with fission engineering in the past. And in the past couple of years, I have been dedicating most of my time to research in fusion engineering. It's mainly because there's so much overlap between a lot of nuclear technologies, and I'm hoping to provide maybe a little bit of different perspective on how we can reach a carbon neutral economy.
Great, well, thank you, all of you. And so that's your panel for today. So I'm now going to kick off with some questions that we already have. So Chris, I'm going to start with you, although the same question is, I'm afraid, going to come to all of you. So Chris, what I'd like you to do is, can you tell us a bit about the specific challenges in the areas that you work in that you see around achieving net zero? And
Sure.
What would you say is needed to overcome them, and what is actually happening within your area of work and with Bristol to overcome those?
Yeah, so I think for digital technology, my main focus is on digital technology and the role of digital technology. And unlike some other industry sectors, I think we can confidently say that in 100 years' time, as part of a zero carbon world, digital technology will be as present and almost certainly far more so than it is now. And so we need to find ways to deliver that technology that we already have in place and allow it to expand efficiently, so that it can work actually as part of a zero carbon world. And to do that, we need to effectively understand the ways to decarbonize the system and also to make it more efficient. And the barriers to that are, first of all, the complexity of the system. The internet spans the whole world. In terms of all the emissions, it's probably about 4% of global emissions, the internet plus all the equipment that's attached to it. Estimates vary, but it's roughly 4%. And many players are involved even in any individual service that we provide. An internet service will involve maybe about 20 organizations. And so we need to work together to understand how to engineer these things. So the complexity of the system is one challenge. The next challenge is the lack of understanding of the system and lack of transparency in the system. And finally, another challenge is the lack of awareness among software engineers. Many software engineers think it's the job of the hardware engineers to make the equipment more efficient, whereas also the way that you develop algorithms, etc., how they work across the internet will affect the amount of energy that is used by the internet. So we need to reduce the energy use overall to allow that sector to expand and play a role over the next 100 years. What are the challenges? Well, we need a culture change in the industry, supported by evidence and tools. And to do that, so effectively, we need the industry to understand its footprint and to find ways of reducing it across the system. And in particular, software engineers and designers need to be involved with that. And the work that we provide at Bristol, first of all, myself and my colleague Dan Sheen, we work on understanding the footprint from an end-to-end point of view of digital services like Netflix, like the advertising services that we're often connected with, and allow alternate design decisions to be explored in those to identify where the hotspots are, to target where we need to work to improve their efficiency and to re-engineering them appropriately. Other academics work in this area too. Ruzana Chityan, she works on thinking about how we can integrate concepts of climate and sustainability into software requirements engineering when you're working out the requirements on any particular software tool. And Kirsten Eder and her team work on energy-aware computation, which is how you can effectively have algorithms which work with a limited energy budget and do not go above the budget of energy they have and deliver the best result they can in that time. So that's broadly what we see the challenges are and the work that we're doing at Bristol to contribute to them.
Great, thanks very much, Chris. And I think that's very interesting, because I suspect when we think about net zero, actually, we very often don't really take on board and think about the digital world and the digital economy, and just how important it may well be. So, I think that's very useful to get those insights. Mahmood, could I come to you next? I mean, obviously you work in a very different area. So how do you see the challenges in your area? What is being done to overcome them, and what's Bristol's contribution to that?
I guess I have to be very honest about it, which is we have been running nuclear power plants for a very long time. We know they work. Sometimes accidents happen. Hopefully they won't happen in the future, because we know how to avoid them. But what's really, really important in nuclear fission, and that's thanks to Paul and his sector pushing us towards that, is bringing down the cost. So right now, nuclear is very expensive, or perceived to be very expensive. And if we want to continue using it, we need to bring the cost down. And the way to do that, fortunately, it's a lot about universities. It's including innovation. Through innovation, we can bring the cost down. Digital is really important. You'd be surprised to know how much we have to put efforts in just to put wireless sensors into a nuclear power plant, because it's so safety critical. We have to be so careful about putting new things. I know a wireless sensor is not particularly new, but it's perceived to be new, in order to convince the Office of Nuclear Regulation that we can use it. We have to put so much effort, so much research into it to convince them that it's safe to use. These days, bringing innovation into nuclear to bring down the cost is the most important part in fission. And when it comes to fusion, we have almost cracked the plasma physics side of it. It's time for engineering. So you see a lot of research being carried out within the Southwest Nuclear Hub in Bristol towards delivering the engineering side of fusion. So we know how to make a plasma. Getting heat out of it, putting it into a turbine, get electricity out of it, is what we are really excited about. And it's, I guess I'm very lucky, because I genuinely cannot think of a more difficult engineering problem to tackle. So it's really exciting. It's so high temperature, so harsh environment. If we can solve that problem, and not the problem, if we can put something together to get the energy out of fusion, we make the fusion work, but at the same time, we are going to produce so much technology on the side that can be used in a lot of other industries. So fusion and fission, bringing down the cost and delivering fusion energy.
Great, thanks Mahmood. And I think, again, really great to see how there is these crossovers between the work that Chris works on in digital worlds, in your world, and different types of challenges. But I also particularly like the enthusiasm for tackling what is a really hard engineering problem. I think we sometimes forget that it's actually really important to care about what you're doing. Paul, I'm going to come to you next, because you share many interests around the energy space with Mahmood. So again, key challenges, how do we overcome them, and what's Bristol's role in doing that?
Okay, so in terms of key challenges, Mahmood touched on cost reduction already, and for renewables, I would say the key challenges are the same. So you've got the much more well-established technologies such as wind and solar, where we need to keep bringing down the costs so they continually become more cost competitive against conventional energy sources. But at the same time, we need to be bringing through the less mature technologies in sectors like the wave and tidal energy industries. Alongside this, we need to make sure that we're developing these devices in a way that they are themselves sustainable. So because of the vast numbers they're being produced in now, we need to make sure that the materials we're using can be either reused or recycled at end of life. And that will be a key challenge going forward in the future. I think another key challenge is around the way we manage our energy supply sources and distribution systems. So bringing down the costs of storage technologies is also key. and becoming smarter at the way we manage our energy systems. And then a key thing in terms of just bringing down the carbon input of our energy supply systems is the electrification of both the heat and also the transport sectors. In terms of some areas Bristol are addressing these various challenges, Bristol's got a very well-established reputation in various types of material technologies. So we're doing lots of work in areas like composite materials, working with partners like the National Composite Centre, both to improve and to make the manufacturing of composite technologies much more efficient, but also to become more sustainable in the materials that we're using. Likewise with storage, we're doing some things around the storage of technologies such as hydrogen, so that we can store them with reduced mass and reduced volume. And then also through the interdisciplinary institutes such as the Cabot Institute, there's lots of more cross-cutting work going on around bringing engineers together with social scientists and actually looking at energy systems as a whole. So it's key that as engineers, we're working with colleagues in the social sciences to actually integrate energy systems in wider society. So that's really key. And I should have mentioned earlier that as well as my sort of research interests, I'm very focused on teaching in my work, and very keen to make sure that we're, as Claire mentioned, inspiring the next generation of engineers to go out and address some of these challenges. So at Bristol, we've got a very strong industrial liaison office, and they've been superb at forging partnerships with industry and academia. And that cuts across both research and also teaching. And I will just make a quick plug now that we've recently launched an industrial placement scheme. So if there are people on the line who are interested in taking students from us on placements, please get in touch, because we're really keen to get our students out into industry and working with you as early as possible.
Great, thanks, Paul, and top prize for you know, spotting the opportunity to promote your placement. So well done. Some really, I think again, really good points there. I mean, you know, cost issues. I mean, I think both you and Mahmood have flagged that up, and presumably that also then has important consequences and implications for the work that Chris will be looking at. I particularly also like the fact that we're flagging up that we have to consider the sustainability of materials we use in renewable energy, because I think in the past, sometimes certainly at a policy level, people have forgotten you need to take a life cycle approach, and they just look at the actual energy generation rather than thinking about all the things that go into make different types of infrastructure that support energy generation. So I think it's a really useful point. Claire, I'm going to come to you next, and again with a very similar set of questions, and I know you have a slightly different sort of focus and background, certainly from Paul and Mahmood. I mean, you are, like me, much more of a water and environmental manager and engineer. You're very focused on teaching. But you mentioned in your introduction about you know, how you're focused about trying to teach and train the next generation. So again, interesting to understand what you see as being these big challenges, how we can overcome them, and what's Bristol's role in trying to do this.
Awesome, thanks, Guy. Yes, we'll talk a bit from a teaching perspective. So I know that University of Bristol, we expose our students to the very best in terms of, I guess, what Chris called evidence and tools, the technology, the science, the engineering methods, all the things that we need to kind of support knowing how to transition to zero. And this is absolutely critical. But the biggest challenge for them, I think, is actually going to be moving into the mainstream and trying to actually influence and transform really the way that governments make decisions, and also how corporations particularly measure their success, because that also drives how they make decisions. So a big focus for me since I arrived in Bristol has been to try to get this interface, this science policy, engineering policy interface, a lot more clearly delineated in our program, and teaching our students that they're going to have to confront these challenges, and they'll need technology approaches, but also I need to understand a lot more about how people think and about how governments think. So, it's quite clear that if we just stick with the old sort of profit-driven, the commercially oriented approaches that you've all mentioned, we're not necessarily going to get to net zero. We're certainly not giving the right signals about what we really value. And our students are going to have to confront some very established thinking when they go out into the world. Let's face it, short-term, profit-driven decision-making priorities in governments and corporations. And so they've got to be able to bring the knowledge base to inform these decisions, but also challenge the underlying criteria that the decisions are being made on. And some of the things that we've been doing in the last few years as part of, we're accredited with the Chartered Institute of Water and Environmental Management now. And one of the things we did there was we thought about having some cross-cutting themes across our program. So things like sustainability and decision-making. And then we've introduced a lot more learning approaches like role plays, hypotheticals, to try to encourage students to understand that challenge, that interface between what they know in the science, and they're very good at science and engineering, and how that actually translates into trade-offs and working in interdisciplinary settings. So we're trying very hard to get them to be more comfortable in those sorts of settings. We have external teachers from the Environment Agency, also some from industry that come in as well and talk to the students, and naturally valuable, I think, for them to kind of start to understand, they've got to come out of this lovely bubble of kind of great theories and understanding and actually think, oh, I've got to do this in the real world. So, this has been a big focus for me. And I think as well, when we think about research, we're broadening the basis of how we value research to society when we're making decisions now about research funding and so on. But, we need to throw a few cats in among the pigeons as well. There's certainly things, why are we still researching concrete as a building material, for example? That's never going to be part of a zero carbon future. So we've also got to be kind of challenging some of this fundamental thinking. We just have to do things differently. And we're now preparing the generation that it's basically make or break. If we don't prepare these kids properly, then they are not going to be able to go out and take on these challenges and deliver us to the kind of future that we need.
That's great, Claire, and I think it's really interesting to get that sort of somewhat different perspective, and that fact that actually part of getting to net zero isn't a simple technical challenge. It's much bigger, more fundamental questions that society needs to ask itself. And as somebody who spent many years working in government, I always love to hear people talking about trade-offs. And I love to hear people are talking about interdisciplinary teams because in the end, the heart of decision making is always a set of trade-offs that you have to make between what you're trying to achieve, because you can very rarely achieve everything. So I think that's a really good starting point that we're trying to get a sense about the challenges, how we're trying to overcome them. I think both Paul and Claire have both, particularly flagged up some examples about where you're engaging with and working with other partners, and I want to spend a few minutes just to explore that a bit further, but perhaps this time starting with Mahmood, because obviously you're involved with the Southwest Nuclear Hub. The whole nuclear energy is clearly it is not just an academic project, it is something that involves multiple real world players. So I think what would be useful is if we could get a sense from you is, to what extent do you see people already being, fully engaged around your research, your other activities? So what's that level of engagement already? And perhaps more importantly, how would you like to see that develop? What more would be really helpful? What other types of organizations or types of engagement would you like to see moving forward?
Well, that's a really interesting subject. When it comes to nuclear, it is so expensive that, or the technology is so complex that you get a few big players ruling the scene. So, for example, you have the kind of Rolls-Royce, EDF, and UK Atomic Energy Authority, but which we connect with them very well. I'm my chair is half funded by UK Atomic Energy Authority. or we just have won a £7 million project with EDF on digital twins of reactors. So there is a very good connection between Bristol and the big players, but they are not the only one. You know, supporting EDF, supporting UKEA, supporting Rolls-Royce. There is a huge amount of companies, all the way from big Atkins, Fraser-Nash, Jacobs, Cavendish, and those guys, to very, very tiny SMEs that 3.5 people are doing something really exciting and innovative. And I guess that's where we would like to expand our collaboration, because we can be the bridge between the small innovative side and the big company. And let me plug that bit. You know, Paul has done a plug-in. Let me plug my bit too. More importantly, I think, is the workforce. Connecting our students with the big companies or with the small companies is something that I see as really, really important, and something that we need to deliver. Because when you look at a lot of the established nuclear companies, you look at the workforce, they are really experienced, and they are, due to different policies of the past few decades, they are mostly either retired or close to retirement. And then suddenly the government has looked down and said, hang on, we really need nuclear. We need some people to run this. So you get a big age gap between the established people and the people who have to go in. So engaging with the early career researchers and engineers and training them and telling them the nuclear is not all evil and you can go in there and you should go in there, I think is an important side. So it's both SMEs, connecting the SMEs with the big companies, and connecting our young researchers and engineers to both the supply chain and the big companies is I think is the important side.
Great, thanks, Mahmood. And I think it's really interesting that thought about how you engage younger researchers. I mean, a number of years ago, I was based in Delhi, and the RC UK at that time was developing new partnerships between the UK and India around nuclear. And one of the main comments that came back in that discussion was the complete mismatch in age between the two groups when they met. Because it reflected this fact that in India you had a lot of younger, quite engineers who were very keen to engage, but often what people were then bringing from the nuclear industry in the UK were people who were much older, much more established. And I think one of the things that represents then is how do you bridge an intergenerational gap to have a genuine dialogue and collaboration, which is not always that straightforward. But that was really great. And I also like the idea about sort of the different types of companies, different sizes. I've mentioned internationally, and Chris, I guess coming to you now, I mean, I guess in your space, probably even more so than Mahmood's space, there is a huge kind of universe of different types of very monolithic organizations and very dynamic small ones, and old and young, and people in the UK, people overseas. So how does it work for you about working with externals, and how would you like to see that develop and grow as you move forward?
Sure. So as you say, I think as I said in my introduction, one of the issues that we have is lack of transparency, and the fact that culture change and cooperation in digital organizations is essential. I would say that digital organizations in general, because many of the American ones at least were set up by kind of 1960s hippies originally, are quite engaged on environmental things. Maybe on tax they're not so good, but on environmental stuff they make a fair amount of effort. And so we've actually been relatively well welcomed as they become more aware of our work. But what I would say is that, so the way that we need to work is we need to encourage companies to work together. So we need to act as a catalyst, effectively, to encourage them to work together. And so the way that we've worked is we started off in the UK, but we're kind of gradually expanding. And we have a consortium of companies that work with us. It's called the DIMPACT Consortium. And they're part of an organisation called the Responsible Media Forum. And what we do is effectively, while they cannot reveal information to each other, they are happy to reveal sensitive information to us. And that allows us to correlate between companies to understand, to help them understand the methodology of how to report, but also help them to understand how to talk to each other about where the hotspots are. And also, if one company appears to have a very different hotspot from another, we can flag that. Is it a data issue, or is it actually an issue that they're doing something different which maybe is inappropriate? And so we can help we can preserve some kind of sensitivity, but allow them to work together. And so we're trying to encourage standards and kind of conversations. But those work for the big companies. For the little companies, I think they're in two categories. The first is the category that doesn't yet know it's important to them. And when I say little company, if we take as an example Bristol University, okay, so Bristol University is only just becoming aware of the fact that the footprint of its digital services, both what we have in-house, our supercomputer, etc., and beyond, are a very significant part of our footprint. And how do we manage that? And so there is something about creating knowledge for these and creating tools which can be used by these smaller organizations to help them. And that is kind of a new thing. That's something that we're just beginning to think about, how we can roll out our findings with the big organization to the small ones. And then in the other category are the small, fast startups that are really engaged around this, that see this as their reason for being. They're kind of introducing new technologies, new innovations, etc., to try to reduce energy use, reduce emissions, circular economy. So one that approached us relatively recently was one that is to do with the circular economy, trying to ensure that reconditioned equipment is used across the internet to reduce the emissions from the manufacturing of that equipment. And again, that's kind of trying to bridge the gap between the small organizations and the big organizations and help those small organizations think about their role in the bigger system. If they can explain how their role fits into the bigger system, then that can help them effectively talk to these larger players and frame their message in a way that those larger players will hear.
That's great. Thanks, Chris. And I think it's really interesting when we start to reflect that, partly that places like universities can act as a broker between, several big players so that there can be a collective understanding of the issues without straying into releasing commercially confidential information, which is always very, very tricky for companies. But I really also like this idea that I think both you and Mahmood has talked about, is that you need to understand how you engage both small organizations and the larger organizations, and this process about how you try to connect them, how you try to get them to talk to each other, see each other's relevance, I think is really important. Claire, I'm going to come to you next, partly because obviously you do work in this slightly different space, but I think also because you were already talking a bit about the courses that you run, and about that trying to engage with a wider grouping. And I'd just be interested to see how you feel that goes at the moment about working with external organizations. And again, what is that we need more of? And perhaps thinking slightly, who are the non-usual suspects? Who are the unusual suspects? It would be great for us to get into the room in order to engage with our students.
Thanks, Guy. Yes, so I've already mentioned the importance of interdisciplinarity and understanding a range of different perspectives. And we do have a few unusual suspects that we're working with. So we do have a good partnership with the Environment Agency, and a couple of staff from there come and regularly teach for us. But also we're forming a partnership with the Bristol Avon Rivers Trust, for example, and they do things like take our students on field trips, our students do some research projects for them as well. So it's been quite a good kind of two-way flow of support and information. And I think for us, because the things that our students will solve are very much very, very real world problems, it's really critical that they're actually out meeting people at work in these jobs, and also doing research projects that actually come from real problems that are being faced by these organizations. So that's been a really interesting, I guess for me, a very rewarding part as well, to feel that we're connecting with some of these different organizations. We do also have a lot of our students end up working in consultancy companies. So we often have guest speakers from consulting backgrounds as well. And that's actually my own background too. So, we try to cut it both ways, because we want the students to understand the sort of environment they might be working in, but it's also really valuable for people to come in and tell our students what kind of things they really value and want them to be doing. So, you know, it's very valuable two ways. And then finally, one of our main collaborators at the Environment Agency, you know, it's actually written into her career goals now that she's going to teach for us regularly, because she actually really enjoys that interaction as well. She says it's really changed the way she thinks about her job. So it's much less commercially driven, I think, for us, and much more driven around the idea of partnerships and collaboration, which, you know, to me are fundamental to sustainable futures as well.
Great, thanks, Claire. And I think, again, it's interesting that, you know, that connection into the regulatory world and into the sort of more policy world, I think is actually really important. And it's important that we, as we move towards net zero, we do recognize this is not just about, you know, technology. It's not just about particular companies. Actually, what policies and regulators set as future direction is really important. And also there, how can we influence them to make the right kinds of choices that reflect the needs of all the stakeholders that operate within the space. So Paul, can I come to you finally? And again, I mean, you mentioned a bit already about, you know, how you work with other organizations, and just be interesting to hear, you know, if you a bit more about what that happens in your space. And again, particularly around renewables, I mean, where do you see the future growth areas where you really want to start working with other people a lot more?
Yeah, I think we're very lucky in Bristol in that we've got a host of leading renewable energy companies right on our doorstep, and that goes from the really big players like DNV to a range of SMEs who we already work very closely with. Some key partnerships include the Blade Research Hub through the Composites Institute, and that's linked to the Offshore Renewable Energy Catapult. And we also work closely with both academia and a range of industries through the Partnership for Research in Marine Renewables. So that's a consortium of research institutes across the UK and also globally who are working on the development of marine technologies. I mentioned about teaching links already. So we've got courses in both wind, marine, and also solar energy now, which are taught almost entirely by industry. So that's a way we're working with industry, both through research and also through teaching. And I also mentioned about the Cabot Institute, which has a great way of helping us to develop links with a range of different community groups, so we can ensure that the research we're doing here at the university can actually have a real impact on the local communities and also communities, well, both across the UK and also globally. So one key point, I guess, to raise as well is that although some of the discussion so far has been very much focused on the UK, a huge energy challenge is helping international development work. So I think one of my colleagues, Sam Williamson, is talking a bit later on about some of the ways we're addressing challenges in the developing world and to increase quality of life through energy supply and sustainable energy in countries, some of the poorest countries in the globe. I think I mentioned as well about the industrial liaison team. So hopefully there are people on the line today who are keen to work with us, who maybe aren't working with us already. And I guess the key thing is to make contact with us, tell us about how you want to work with us. And there are a range of different funding schemes, both for the larger companies and the very large scale research projects to small scale pilot studies, which can help you engage with the university. So hopefully we'll be able to help address those needs if you get in touch with us.
Great, thanks, Paul. And I think that's some really good examples there, both the engagement, teaching and research. And just to echo your points, I mean, about a global footprint, I mean, a lot of the area that I work on is focused on low and middle income countries, and the delivery of energy security in many of those countries is a massively high priority, because you know, if people start to have access to reliable, affordable and sustainable energy, it can be genuinely transformative in social and economic well-being. Trying to use my words carefully so I don't fall foul of Claire's views around not changing our view, our perspectives. But access. I mean, I think we forget sometimes when we live in the UK just how important electric light is. And just to give anecdotes, I mean, if you're a poor girl who lives in Nepal or Bangladesh, for instance, your ability to study at night will be entirely constrained by whether you have electric light that's reliable, so you can study for 2 hours in the evening or not. And that can be, the difference between life-changing qualifications and not, and being constrained by what you can do in the future. Okay, we've talked a lot about specific things around what we do in Bristol and how we view things. So I want to sort of try and broaden this out a little bit further for a couple of questions before we go to the audience. So the first one is going to be really, I think, focused more towards Chris and Claire, which is, if we take a step back, and I think, Claire, you've already talked about this, take a step back, what is it overall that we need to be doing that as a society, as a global society, that will get us to net zero? And what are the things that we need to see changing in industry, in government, in society to achieve that? And what is it that we think from our side, from academia, that we can contribute and help influence on that? So I'm going to start with Claire, and then I'll come to Chris with the same kind of question.
Thanks, Guy. And you've already stolen my favorite word, which is transformative. It's my new word that I'm using all the time, because I come back to a saying, I think it's attributed to Einstein, although it may have been misquoted, but basically you won't solve the problem with the same kind of thinking that caused it. And if we don't get our heads around that, then we're not going to solve this problem. And so we have what Chris called the evidence of tools. We've got technologies getting better and better at the moment, but already both Paul and Mahmoud have spoken about it being commercially viable. Basically, we will not bring things into common use unless they're commercially viable. And this is driven by a very particular economic paradigm that we're sort of living with in the Western world, at least, is neoliberalism, basically maximising short-term profit. And our government's policies and the way that our organisations behave actually encourages us not to think about side effects, externalities and those sorts of things. So I think that we've really got to bring our environmental and social indicators much back to the fore of our decision making and our thinking. Before I came here, I spent about 25 years doing environmental impact assessments, and consistently, I think we do quite a good job of them, but consistently you see the decision making being dominated by the financial job creation type criteria, contribution to GDP, those sorts of things. And so the trade-off always seems to go against environmental protection and biodiversity protection and so on. So that's one thing that needs to come back into balance. But the other thing that we've really let slip is our social metrics. And it seems strange to talk about that with an engineering forum, and yet it's exactly the kind of forum that we need to learn to talk about these things a whole lot more. As part of the problem, how does our research and our teaching contribute to quality of life? What is quality of life? I mean, the pandemic has kind of made many of us stop and think about this a little bit, but it's also shown that we live in an increasingly unequal society, many people in very precarious positions. Guys mentioned energy security, water security, food security is increasingly threatened, not just by climate change, but also by the inequality that is growing and growing in our society. 20 people control about 50% of the world's wealth. Now that, that is, it used to be 26 and it's coming down all the time. Our life expectancy is going down in Western countries. And unless we, as the kind of technology side of things, the science and engineering side of things, don't get more comfortable talking about environmental and social metrics and these sorts of things, then I don't think we're going to be able to be part of this conversation of how we change, how we transform the way that we make decisions. We've got to get ourselves more familiar with these concepts and be able to use them all the time in our day-to-day discussions. So it's not just how can I make this nuclear reactor more viable, but why do we want a nuclear reactor? Like, what are the benefits it's bringing us? It's going to help that girl in Nepal get her degree. I mean, we're just not valuing or adding these things to the equation well enough. So that's my transformative soapbox. But, you know, very different ways of thinking for those of us that are very, very entrenched in science and technology. But we've got to start speaking this language.
Great, thanks, Claire. And I think, I mean, actually, funnily enough, I probably would argue that, you know, an engineering forum is exactly where we should be talking about how we change societies and take into account social needs, because, I mean, engineering is all predicated on meeting the needs of human populations. I mean, this is why we do it. It's why we generate energy, or we deliver water, or we develop new digital technologies. So I think the engineering community has a profound role in that. And I think it also has a very key role in being able to articulate costs and benefits of different approaches, and making sure that the benefits are framed as widely as we can. So Chris, can I, you know, you'll have a different perspective on this, obviously coming from a digital perspective, but I'd be interested in your views again about this broader perspective.
Sure. Actually, what I'd like to do is actually at the same time, so I might take slightly longer than my allocated time with you, to answer Harshini Gourdoyal's question, because it directly links to this. So Harshini asks in the Q&A, there's a lot of ongoing research on the use of machine learning and renewable energy generation. How can we ensure that the gain from these digital technologies is greater than their footprint? And so you're absolutely right, Harshini, that when we look at digital technology, it can be used in ways to move us to a zero carbon society, renewable energy, for example. And so, in fact, the argument has been made by the IT companies. And in fact, I used to work for Hewlett Packard, and part of my job was to make this argument to everybody, was that if you look at the actual impact of digital technology, it's quite small when you compare it with all the good it can do. And when you see the kind of markups, you see estimates of like maybe about 15 to 20% of emissions can be eliminated by digital technology. So that's the argument that the IT companies made. So you don't need to worry so much about the footprint of the digital because we're doing so much good. But the problem is, if you look at the way that IT is delivered, it also does a lot of bad. IT is used at the moment to, for example, make efficient the extraction of tar sands in Canada. Without the sensor networks that are put in place in Canada, it would be uneconomic to extract that tar sand, which is worse than coal from an energy generation point of view, from carbon dioxide. So it's wrong to say that IT just does good. So Harshini's point is absolutely right. How can we ensure that the gain is greater than their footprint, or even than the negative effects that they can have? And so that's a really good question, and I think it goes right to the broader question that Guy has asked, which is what needs to be done more generally. And if you look at it, and as Claire has pointed out, effectively, companies choose or are constrained by financial reality, which does not necessarily embed in it the externalities and the environmental priorities which the globe is beginning to move towards. And so with digital technology, it will accelerate us faster in whatever direction we choose to point society. If we choose to point in a high carbon society, it will move us to a high carbon society faster than we would do otherwise. If we choose to point towards a low carbon society, it will move us towards a low carbon society faster than we would do otherwise. And so the question is, which way do we point? And I agree with Claire about values, etc. However, I would also say that I think we need to accept that there will be a political debate. So what can be put in place in the relatively short term that people on the left and right, on the more libertarian authoritarian axis, globally, can agree to? And I would say, as an idealist, I would say we need to embed planetary boundaries into our economic system. And by planetary boundaries, it's partly, so net zero is one of those planetary boundaries, but other things as well. So nitrates and phosphates to do with agriculture, biodiversity. There's a number of planetary boundaries which we effectively need to develop an economy which fits within these planetary boundaries. And if I focus on net zero in particular, the way we need to do that is something around a global price on carbon. So a global price on carbon which is effectively in line with the scientific targets. So not just the kind of arbitrary one that's generated through some arbitrary negotiation, but one that is in line with a net zero descent path, which means by 2030, reducing our emissions by 50%. I think, if I got that, I can't remember exactly, I might be wrong there. But effectively, it means having that in place. So that means we need to cooperate globally. And that means a combination of carbon pricing in places like Europe and China, but also border adjustments. When emissions are going across borders, when things are being moved across borders, there needs to be taxes in place to compensate if the country they're coming from does not have carbon pricing in place. So that's a kind of a more technocratic position than Claire's, but I think it's that doesn't mean I don't agree with what Claire said, just to be clear, but I think these technocratic answers need to also be put in place, as well as working towards more fundamental changes of priority in the longer term.
Great, thanks, Chris. And there's some great points there, and I think the idea about planetary boundaries and the degree to which we can then start to define them and work within them, I think is increasingly where lots of different sectors are going. So certainly, for instance, in the health sector, the idea about health operating within a planetary boundary is getting a lot of currency now. And I think maybe we need to think of that more broadly. And I agree. I mean, carbon pricing is an excellent, is a very good instrument if you can make it work well. It does require also really good economists engaging on how you set up and properly price and properly regulate financial markets that then use carbon pricing, because that hasn't always been that successful in the past, and people have been able to game systems quite well. But I think it's just because we haven't been perfect the first time we've tried to do something doesn't mean that we shouldn't try to keep on doing it to make it much better. And I agree. I think these answers are a mixture of both technocratic and of these broader, more philosophical bases. I don't think you can have one without the other. So that was great. Okay, the last sort of question I wanted to pose really before we go to the questions from the audience, although Chris has successfully managed to deal with one of the audience questions already. So that was very good, very effective use of time. So the final question, I think, is now more focused to Paul and Mahmood, which is really around, can these alternative energies work globally? I mean, we know alternative energies can work locally and nationally, but can they work globally? Can we displace fossil fuels from being the predominant energy at a global scale? And do we have particular views on where would be good or bad for nuclear energy to be put in place? Do we have particular views about where it would be good or bad for offshore renewable energy to be developed, for instance? So slightly different takes on it, but perhaps Paul, if I can come to you first. So the big question is, can renewables work globally? But are there places where certain renewables would not be a good thing to pursue? Let's frame it that way. Let's assume they would normally be good, but there may be places where it would be bad.
So definitely, yes, renewables do have a role globally, and the best combination of renewables is highly dependent on location. So depending on the solar resource, the wind resource, or if it's close to a marine environment, the wave and tidal resource, that will dictate the best combination of renewables in any single location across the globe. And of course, the local economic and social conditions into which they're being placed, and constraints such as land and planning constraints, the skills available in terms of local communities, that's going to have a huge impact on the best combinations of different renewable energy supply types, depending on where in the world we're looking to develop those technologies. So I know it's a bit of a wishy-washy answer, but it's so site-specific in terms of renewables, but there's a place for them everywhere, but that role depends to a huge extent on exactly where you're putting them, both in terms of the resource in that area, but also the local social, environmental, and economic conditions.
Thanks, Paul. But just to rather cheekily push you on it. So if you had to choose two renewables which you think have the greatest global application, which ones would you go for?
Well, I guess the obvious ones to go for are wind and also solar. And certainly in terms of wind, the offshore wind energy market is the really big growth area at the moment, because it overcomes many of the objections around wind towards planning, noise, and other social concerns. But at the same time, a lot of the best wind resource is in areas of deep water where traditionally you can't locate fixed foundations. So there's a big push at the moment towards floating wind energy technologies. Solar is deployable across the globe. In some nations you have better solar resource than others, but everywhere you get daylight and the ability to generate solar energy. And then the more niche technologies such as wave potentially is a global player in terms of the marine environment, but tidal stream energy and tidal range energy, although it's got a role to play, is very highly site specific. So there are only a relatively small number of locations across the globe, and the UK is one of the key ones where those technologies can be, well, both technically and also commercially viable.
Great. Thanks, Paul. I'm sorry to push you a bit on that, but it was useful to get that answer. And I think I like also the point that you're making is you do have to think about the wider implications. So I work a lot of around water, and in the past I've worked a lot around hydropower. And as anybody who's ever known who worked in energy, hydropower is probably at least as contentious as nuclear in any particular setting. So understanding the local context, I think, remains really important. So Mahmood, just in this final one, so obviously, it's a big question. I mean, does nuclear have a global application? Are there certain places in the world where you might think it would be a really bad idea to start building nuclear reactors, for whatever reason, for environmental or social or political reasons? So what's your view on that? I mean, what is the global reach of nuclear, and should it be a big player globally?
I guess for a while we had gone towards the bigger the better. So if you look at the European pressurized reactor that we are building in Hinkley Point C, it's a £20 billion project. It's one of the most expensive things we can do, and of course we are going to get the benefit. But the UK is a very good place to build something like that because we are so densely populated, and there are lots of countries like us that can build really big. And by doing that, bringing down the cost. But when thinking about the other parts in the world, if you have a very sparsely populated country, let's say like South Africa, then we need to use a different design. So there is a very big push towards small modular reactors, which are a lot. They're getting some benefits. You make it smaller, you can build a lot of them. You can, like a car, it's like Ford did this 150 years ago. Maybe we can do the same thing with a nuclear, smaller, a lot of them, bringing down the cost towards by doing that. And a lot of countries that are not so densely populated can benefit from a small modular reactor. And that's not just in fission. In fusion, we have the same thing. So to steal Chris's idea and answer two of the participants' questions, are we ever going to build a fusion reactor? Yes, we are. And the way to do that is to make them smaller. So if you look at the small tokamak for energy production, the STEP program, it's supposed to be much, much smaller than, let's say, the demo fusion reactor. That is going to be really big, and we are going to build one prototype by 2040. So again, smaller, cheaper. You can put it everywhere, and we can make it quicker by 2040 to show we can build fusion power plants. So I guess it's all depending on where you are and selecting the correct design for that environment.
Great, thanks, Mahmood, and brilliant. Because I think you've started to answer some of the audience questions, which was also really helpful. But I think this idea about understanding that different types of nuclear facility would be required in different settings is actually a really important one, because I think many people would always be concerned about huge, enormous, great facilities being placed in places where there's questionable political governance, or there is perhaps a set of environmental reasons which would make it inappropriate. So I think that's a very good answer. And you answered one of the nuclear fusion questions came up. But can I just push on the second one is, do you think will nuclear fusion be contributing to net zero by 2050? Or are we really looking at that as being something that happens after 2050?
Well, I personally really think we can, because looking at the technology, we are almost there. What we are worrying right now is how to weld a pipe to our nuclear power plant. If we are there, we are going to build one. But don't take my word for it. By 2040, the UK government has promised to build a prototype. And if the prototype is ready by 2040, I think by 2050, we are going to have a couple of them out there. But I can answer that question, I guess, with confidence in 2040.
That's a very, very, very good answer.
Classic fusion, I'm kicking the can down the road.
So that's great. So we're going to go in, and I'm going to try and pull out some of the questions that have come up in the Q&A. I think one or two of them have been answered already, and I think there's another one from Mark that I think, Chris, you're happy to answer live. And in fact, well, actually, maybe we should take that one now, which is, what do we think about, who is really innovative? Is it only the small companies, or is it bigger companies? And what is the role in which university can interact with those different types of organisations to encourage that innovation?
Yeah. So yes, I think, I just used the standard cliche of the small innovative startup when I spoke earlier on, which I think Mark understandably picked me up on slightly. I think bigger companies can be very innovative if they're structured to allow them to do so. I think some companies can, and I used to work for Hewlett Packard, and Hewlett Packard for a long time was structured as a company which encouraged innovation through the way it worked, a relatively decentralized format, together with a central research lab that was not expected to produce payoff in the very short term. I think that's probably what it is. And I think that Google to some extent has that now. Hewlett Packard no longer does. It's become more of a, it's been split up into several pieces, but it's become more of a Turner-handled kind of cash cow organization. Probably slightly unfair there, but it's become a lot more kind of, it's moved to a different place in its life cycle, whereas it used to be more innovative. So I think big companies can be innovative, but it's very much a cultural thing. And that innovation can also address the issues that we're talking about today. But the community, not just the engineers, but the community in the company needs to be empowered to do so. So there needs to be clear kind of encouragement from the top that this is an important priority. So I think that's, hopefully that will answer your question, Mark.
Great, thanks, Chris. Right, I just wanted to pick up a couple of questions from Mark, who's been very active on the Q&A, which is very good. But I'm going to roll them both together. So there's a question about what the key changes we think we'll see in education in the next 10 years around that, in the context of driving towards net zero. But then also linked to that is, the idea about benefits being measured in broader terms. What are we doing from an engineering perspective to engage with economic disciplines to actually try and engender that debate and engender that change? So if I could roll those up together, maybe it'd be useful if I could come to both Claire and then to you, Paul, to try and get your thoughts on that, because you both talked a fair bit about your teaching, and so you might be quite well placed to answer those. So Claire, can I come to you first, and then?
Thanks. Yeah, very, very interesting questions. I've actually, one of my little lockdown projects was to try to read a bit more about economics, because I'm a scientist, my background, a degree in chemistry originally. And I thought, if I'm going to beat these economists at their game, I better understand more of it. And it was really educational, because I kind of began to understand the economy not as this kind of big enemy driving us to, consume and consume and consume, but actually a system that we can use to distribute goods and services and wealth and all those sorts of things. And it entirely depends how we set that up. And so I think we've sort of ended up with this kind of us and them thing, with the financial sector doing its thing and the rest of us kind of going, I don't really understand that, and it's all economics, I don't really get it. And maybe we actually need to bring this back into our day-to-day language as well, because the economy, I mean, it's a thing that we created, right? We humans created it, and we need to make it work for our purposes. But most of us have so little understanding of it that we don't really know how to do that. I'm desperately trying to work in something around natural resource economics, for example, into water and environmental management course, because I think, that was very transformative for me many years ago to learn a little bit about that. Ideas about discount rates and all sorts of things, which are quite difficult concepts until you finally get them explained to you. And then you sort of, oh yeah, it all falls into place. So I'm kind of rambling a bit, but I think we actually do need to bring economics back into integrated back into everything that we do and that we teach, but also much broaden our understanding. So, we often talk about sustainability as economic, social, and environmental. And to me, that's a real mistake, because we're then dealing with three different things. And the economy in particular it's our tool. We need to learn to use it in a way that drives the outcomes that we want. So I'm not quite sure how I'm going to go introducing economics into engineering degrees, but somewhere along the way, I think, we've got to better prepare our students not to just leave all that stuff to the economists and the financial sector, but to become more conversant and more generalist in some of these things.
Thanks, Claire. Paul, can I just, your thoughts on that?
Yeah, it's really just to build on what Claire has said already, in that we need to be equipping engineers with the knowledge about the broader societal context in which engineers operate, and making them really inspired to go out and address some of these key challenges. So there's a generic area around skills for employability, which applies across engineering, but in specific reference to low carbon energy, I think links with the low carbon energy industries, and giving students access to those industries right from the outset of their degree courses, to actually inspire them and to go on and address some of the low carbon energy challenges is key. So making them aware of the problems early on, giving them access to appropriate mentoring, allowing them to go out on placements, and then ensuring that some of the units they do in the final years of their courses are strongly linked to industry, if preferably taught partly by industry, where they're working on realistic projects that they will face when they actually go into an industrial environment in their future careers, is key. So it's not really a case of doing anything significantly different to what we're doing now, but doing more of the same in order to encourage more engineers to go into the low carbon energy industry in the future.
Hey, thanks, Paul. I'm a bit conscious on time and we're almost finished. Chris, there were a couple of questions specifically around digital. One was about how we make digital infrastructure accessible and adaptable to a wider audience, and what interventions are needed to tackle energy-hungry digital tech that transcends national borders. Are you able to give a 1-minute answer to that? If not, I'll let you off the hook and you can reply another time.
I can answer the first one, but I would be very interested if people want. I can also answer the second one. It takes about 5 minutes, the second one, though my earlier answer is some way to that. The first one, so this was from Vishnav, who says, okay, how can we make these infrastructures accessible and adaptable to a wider audience? I think that's a very good question. And it's really important that we think about, when we deploy these technologies, particularly in the global south, that we meet the genuine needs of the people who are in the global south, which means effectively it needs to be led by the people in the global south in terms of what their needs are. And so we are actually at the moment, so we've got a specific project we're working on at the moment, which is with pastoralists in the Horn of Africa area with regard to climate warning information systems. And designing appropriate mobile, effectively provision of service to these people. And effectively to do that, we need to have participation at all levels, from the people who will use it in the end, but also the community, effectively the Kenyan and Somalian networks of information, and make sure that we work very closely with these organizations, that in the end they lead and they own what comes out of it. So I would say in the end it's about empowering participation of the end communities that will really benefit from this, which allows it to be accessible and adaptable to a wider audience.
Great, thanks very much, Chris. And it may be if there are other questions that we haven't managed to cover fully during this session, I'd encourage you please to get back in touch with us and see if we can then get an answer to you directly. I think we need to start to wrap up now. I know there was a couple of questions in, and I'm going to use this as part of my wrap up because I think they relate to that. I mean, I think the first is, and Vajnav, I mean, what do we do? It's fine, we're making all these great new targets, and at the moment we think the benefits will outweigh the risks. But what happens in the next 5 or 10 years is we suddenly find out that's no longer true. I mean, I think the short answer to that is what we need in a kind of changing world are policy and science responses that are inherently flexible and adaptable. And what we have to avoid is locking ourselves in too quickly to decisions that we can't change relatively easily over the short to medium term. So I think it means that when you're making very large investment decisions around infrastructure, it's being really sure that if it's you're confident that it's infrastructure that will definitely be needed and will definitely be resilient to the future changes over its full lifetime. And I think what I would say, again, putting my former kind of policy hat on, policies that work best are the policies that always leave open future adaptation and change in response to evidence. And bad policy is policy that's made only on the evidence that's available now and then is not able to change subsequently. And I think what climate change tells us more than anything, and a bit like the COVID pandemic, is flexibility in decision making and policy is absolutely critical if we're going to tackle global challenges. Perhaps I'll let Paul in slower time answer the renewables skepticism question. I mean, personally, I think one of the big questions is about demonstrating you can meet base load as well as peak load. And there's a whole sort of long involved energy use and economic arguments that can be deployed around that. But put simply, that's what you've got to demonstrate, because what fossil fuels have always given us is base load. So I'd like to just wrap up now. I mean, I think this has been a really useful session. Hopefully, what you will have taken away from this session is some really interesting insights from a range of different disciplines, spanning everything from renewable energy to nuclear, to water and environmental management, to digital futures, but all focused around that net zero target. I think we've learned a lot about the things that we're doing in Bristol. I think we've understood and discussed quite a lot about the challenges, both technocratic, but also more philosophical. And I think what I take away more than anything is a real sense of basically the enthusiasm and for, if you'll pardon the pun, the energy in this space about how we tackle these problems. And perhaps most fundamentally about how we see ourselves as engineers as tackling society's problems and being willing to engage with other disciplines in order to find solutions for the future that are socially, environmentally, and economically sustainable. So with that, I'd like to thank everybody for participating. I'd like to extend a particular thanks to all the panelists for giving up your time and giving such good and thoughtful and insightful answers. And of course to the team who work as ever in the background to make sure that these events actually run smoothly and try to keep me at least on an approximation of time. So thank you very much, everybody. Have a great rest of your day. And I hope you will join some of the other events that happen during the showcase. Thanks very much.